Number 1, x squared minus 7x plus 1 equals 0. That is a quadratic.
Fat Math, the right path to develop the fat brain that you've got. Hello everyone and welcome to Fat Math TV.
Objectives in this video, you should be able to define a quadratic equation, determine whether an equation is quadratic or not, transform a quadratic equation to its standard form, and determine a, b, and c in the standard form of the quadratic equation. Quadratic equations. A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written as ax squared plus bx plus c equals 0. So it has to be of degree 2, meaning to say the highest exponent is 2. And then this ax squared is called the quadratic term. This bx is the linear term, and this c is the constant term. So if the quadratic equation is written in this form, then it is said to be in standard form. So here, a, b, and c are real numbers, and a is not equal to 0. What do you think will happen if a is equal to 0? This term here is going to be 0, and the remaining terms will be bx plus c on the left side, and that will make the equation a linear equation. So it has to be, or a has to be a real number not equal to 0. Example number 1, 3x squared minus 2x plus 1 equals 0. Is this a quadratic equation? Yes, because we have here degree 2. And then this is also in standard form because it looks like this one. So here in this example, our a is 3, this one. Our b is negative 2. And our c is this one, 1. So the quadratic term here is 3x squared. The linear term is negative 2x. And 1 is the constant term. Let us have another example. Example number 2, x squared minus x minus 7 equals 0. So this is also a quadratic equation in standard form. And a is 1 here because there's no number written here. So it's understood that the numerical coefficient of x squared is 1. Same here in the second term. This is negative 1. So b is negative 1 and c is negative 7. The quadratic term is x squared, this one. The linear term is negative x, and the constant term is 7. Example number 3, 8x squared plus 7x equals 0. So is this a quadratic equation? Yes. Is this in standard form? Yes. So our a here is 8. And our b is 7, and we have no constant term here, meaning to say our c is 0. How about this one? Is this a quadratic equation in standard form? Yes. Our a is 1/2. Our b, we don't have a term here for bx, so b is 0, and c is 9. So it's very important that you know how to identify the A, B, and the C, because later on you will be using them if we're going to have the quadratic formula or solving this quadratic equation. So this is example number 4. How about this 5x times 2x plus 1 equals 4? If we will distribute 5x, we're going to have 10x squared plus 5x equals 4. Of course, this is not yet in standard form because the standard form has to look like this. Ax squared plus bx plus c equals 0. And then we have to add negative 4 to both sides of the equation, and we will have 10x squared plus 5x minus 4 equals 0. And this is now in standard form. So the standard form of the original equation, this one, is this one. And as what we can see here, a is 10, b is positive 5, and c is negative 4. How about this one? This is also a quadratic equation but not in standard form. What are we going to do to make this in standard form? We will expand and simplify. So we're going to have 2x times 2x. At 2x times x, that's 2x squared. 2x times 1, that's 2x. Negative 5 times x, that's negative 5x. Negative 5 times positive 1, that's negative 5. And then add negative 3 to both sides of the equation, or if you will transfer it here, it's going to be negative 3. And what's left on the right is 0. And then simplify, combine like terms. You can just copy 2x squared, but for the terms, for the linear term, we have 2x minus 5x. That's going to be 3x. And then negative 5 minus 3, that's negative 8. So this is now a quadratic equation in standard form. So what is our a here? A is positive 2 and b is negative 3, and of course our c is negative 8. How about this? X minus 4 times x minus 1 equals 2x minus 1 squared. So 2x minus 1 squared is 2x minus 1 times 2x minus 1. So expand and simplify both sides of the equation. X times x is x squared. X times negative 1 is negative x. Negative 4 times x is negative 4x. Negative 4 times negative 1 is positive 4. 2x times 2x is 4x squared. 2x times negative 1, that's negative 2x. Negative 1 times 2x, that's negative 2x. And negative 1 times negative 1 is positive 1. And then we will have x squared copy. Negative x minus 4x is negative 5x plus 4 copy. 4x squared put to the left side, that's going to be negative 4x squared. Negative 2x minus 2x, that's negative 4x put to the left. You will have positive 4x, and this positive 1 put to the left, it's going to be negative 1. And what's left on the right side of the equation is just 0. Combine like terms, x squared minus 4x squared, that is negative 3x squared. Negative 5x plus 4x, that's negative x. 4 minus 1 is 3 equals 0. So this one now is in standard form with a equals negative 3, b equals negative 1, c equals 3. Okay, let us check if you already know how to identify whether the given is a quadratic equation or not. So pause the video if you want to answer all of them before I reveal the answers. Number 1, x squared minus 7x plus 1 equals 0. That is a quadratic equation because we have here degree 2. And then number 2, this is also of degree 2, so this is also a quadratic equation. This is just of degree 1, so that's a linear equation. This one is of degree 2, so that is quadratic equation. This one is not simplified yet. You can expand this and simplify, but still you will have degree 1, so that is not a quadratic equation. If you will expand and simplify this, you will have a 6y squared, so that is a quadratic equation. This one, 7 plus 2p equals 0, is a linear equation, so that is not quadratic. This one is going to be 5 times 420 minus 5c, so not a quadratic equation. This one, if you will expand, you're going to have a 9x squared. That is quadratic. And this one here, you will have x squared if you will expand and simplify. So this is also a quadratic equation. So we have 6 quadratic equations for this set of practice or set of exercises, and then 4 not quadratic equations. Okay, set number 2. Write each quadratic equation in standard form, then identify a, b, and c. So for number 1, we have 6 minus 2x equals x squared. Pause the video. If you're not ready yet, you can try them all. And then play if you're ready to answer. So for the standard equation, that's going to be negative x squared minus 2x plus 6. You just put the positive x squared to the left side and then rearrange them in such a way that the quadratic term will be first, and then the linear term, and then the constant term. So you're going to have negative x squared minus 2x plus 6 equals 0. So A is negative 1, B is negative 2, and C is positive 6. Number 2, s squared equals s. The standard form of that is s squared minus s equals 0. A is positive 1, B is negative 1, and there is no constant term, so C is equal to 0. Number 3, that's going to be 6y squared minus 16y equals negative 1, and then put negative 1 to the left. That's going to be positive 1. So the standard form is 6y squared minus 16y plus 1 equals 0. So A is 6, B is negative 16, C is positive 1. Number 4, 3x minus 1 squared equals 1. That's 3x minus 1 times 3x minus 1. That is 9x squared minus 6x plus 1 equals 1. Add negative 1 to both sides of the equation. You will have 9x squared minus 6x equals 0. So A is 9, B is negative 6. No constant term, so C equals 0. Number 5, that's going to be x squared minus 16 equals 2. So that's x squared minus 18 equals 0. For A, that is 1. For B, there's no linear term, so B is 0. And C is negative 18. So it has to be negative 18. Not positive 18. So negative 18. So C is negative 18. So that's it for quadratic equations. Thank you for watching. Comment, like, and subscribe. Bye!